Hello, my name is Cindy Williams, and today we'll be talking about sum and difference formulas. The sum and difference formulas of both sine, cosine, and tangent are used to find the exact values of trigonometric functions that do not appear on the unit circle. So here are the equations for sum and differences. Let's start with sine. So we have sine of u plus v is equal to sine u cosine v plus cosine u sine v. So for one multiplication part, you will have sine of u cosine of v. And for the other one, you will have the same thing, but the u and v will be switched. So this is cosine v here, it will be cosine u over here, in simpler terms. So next is sine of u minus v is equal to sine u cosine v minus cosine u sine v. For cosine, you have cosine u plus v is equal to cosine u cosine v minus sine u sine v. So it's different from the sine equation because cosine will be in its own little section and the sine is different. So if it says addition in here, it'll be subtraction out here. So cosine u cosine v minus sine u sine v. And for subtraction will be cosine of u minus v is equal to cosine u cosine v plus sine u sine v. Like tangent of u plus v, it would be tangent of u plus tangent of v of 1 minus tangent u tangent v. So similar to this, the sign of this part down here will be opposite. So this is plus, therefore this will be minus. And this of tangent of u minus v will be tangent of u minus tangent of v, and that's all over tangent plus tangent u tangent v. So once again, this would be opposite, and the rest of it would be pretty simple. So the actual purpose of these equations is to find the exact value of angles that do not appear in a unit circle. So for example, 75 degrees does not appear in a unit circle because if you think about it, it's only 30, 45, 60, 90, 135, 150, 180, things of that nature. So I like to break this down in steps. Step 1 would be substitute. So if I have cosine of 75, I will need to break this down into an equation that makes sense on a unit circle. So I think what two angles add up or subtract to get you 75? That's on a unit circle. So I know 30 degrees is on a unit circle, and I know 45 degrees is on a unit circle. And 30 plus 45, coincidentally, has to be 75. So I'm going to use these angles. And I'm going to put these into the cosine u plus v equation. So this is step 1 substitution. So you have cosine of 30 plus 45 is equal to cosine 30 cosine 45 minus, because remember, if there's a plus sign, that means it's going to be the opposite, sine 30 sine 45. And that's step 1 done. I labeled to substitute again because if you remember from basic trig, there will be the cosine value based off the unit circle. So the cosine of 30 degrees, which I wrote up here for reference, the cosine of 30 degrees, which is also the cosine of pi over 6, is equal to root 3 over 2. So root 3 over 2 times cosine of 45 degrees, which is root 2 over 2, let's put this all in parentheses, minus sine of 30, which is 1/2, times the sine of 45, which is root 2 over 2. Now step 3, I say solve. So you just multiply out what you got up here. So root 2 times root 3 is equal to root 6. And 2 times 2 is equal to 4. Minus 1 times root 2 is root 2. And 2 times 2 is equal to 4. So you can simplify this in saying root 6 minus root 2 is equal to 4, which is the cosine of 75 degrees. And now let's do the sine of 105 degrees. So the first step we have to do is to figure out angles on the unit circle that add up to get 105. So I know that 60 is on a unit circle because that is pi over 3. And I know that 45 is on a unit circle because that's pi over 4. And 60 plus 45 is, guess what, 105. So we can use that for our equation. So we just plug that in. Remember, step 1 is substitute to the sine u plus v formula. So it's sine of 60 times cosine of 45 plus cosine of 60 times sine of 45. And now the next step is to substitute again. So sine of 60 degrees would be root 3 over 2 times the cosine of 45 degrees, which is root 2 over 2, plus the cosine of 60 degrees, which is 1/2, times the sine of 45 degrees, which is root 2 over 2. And the last step is to multiply and solve. So root 3 times root 2 is root 6. 2 times 2 is 4, plus 1 times root 2 is root 2. 2 times 2 is 4. So these are common denominators, so you can add them. So your final answer will be root 6 plus root 2 over 4 is equal to the sine of 105 degrees. Okay, now let's try the tangent of 195 degrees. So once again, let's think of angles that add or subtract to get 195. I know in your circle that 225 is an angle, and 30 degrees is an angle, and 225 minus 30 is 195. So let's plug that into our tangent problem. So we have tangent of 225 minus tangent of 30 over 1 plus tan 225 tan 30. So our first step is to substitute. So the tangent of 225 would be it would be 1. So it would be 1 minus tangent of 30 degrees, which is root 3 over 3 over 1 plus 1 times root 3 over 3. So we have, let's make this so that they are able to add together. No, let's leave it like this for right now. So we have 1 minus root 3 over 3, and if we simplify this, we have 1 plus root 3 over 3. So now what we must do is multiply by the conjugate in order to get rid of this denominator. Root 3 times 1 minus root 3. So now we just distribute this out similar to like a FOIL method. So 1 times 1 is 1. 1 times negative root 3 is negative root 3. Negative root 3 times 1 is negative root 3. And negative root 3 times a negative root 3 is a positive 1/3, because root 3 times root 3 is the square root of root 3 times root 3 is 3, and 3 times 3 is 9, so that will be a positive 1/3 because it's 3 over 9. So let's do it down here. 1 times 1 is 1. 1 times a negative root 3 is negative root 3. A positive root 3 times a 1 is a positive root 3. And a positive root 3 times a negative root 3 is a negative 1/3. So now, looking at this, you can cancel these out because it's basically, they're subtracting from each other. So we have 1 minus 2 root 3 over 3 plus 1/3 over 1 plus 1/3. And what I like to do is turn these into fractions in order to make these combine. So 1 is equal to 3 over 3, because 3 divided by 3 is 1, plus 1/3 would be a 4 over 3. So at the top you have 4 over 3 minus 2 root 3 over 3. And you have a negative 1/3 down here. And this turns into 3 over 3. So 3 minus 1 will be a 2 over 3. So now, what you can do is, to get rid of this, is multiply by the reciprocal. So you have 4 minus 2 root 3 over 3 times the reciprocal of 2 over 3, which is 3 over 2. So you multiply this whole top portion by 3 and the bottom portion by 2. So you will have 12 minus 6 root 3 over 6. And 6 is a common factor, so you can take this out. And you will have 2 minus root 3 for the tangent of 195 degrees. Let's do a problem using a ratio. So we have sine of pi over 12. Now this may seem a little bit harder, but actually it's a little bit easier to me. So sine of pi over 12 is equal to sine pi over 3 minus sine of pi over 4. So we can just plug that right into our sine equation. So we have sine of pi over 3 times cosine of pi over 4 minus cosine pi over 3 sine pi over 4. So now all we need to do is substitute again by finding these values. So the sine of pi over 3 would be root 3 over 2, and the cosine of pi over 4 is root 2 over 2 minus cosine of root 3, which is 1/2, times sine of pi over 4, which is root 2 over 2. I meant to say pi right here. All we do is multiply these out. Root 6 over 4 minus root 2 over 4. And similar to one of the last problems, you get root 6 minus root 2 over 4 for the sine of pi over 12. So we can also use some indifference equations to derive reduction equations. So here we have tangent of theta plus 3 pi. So all we have to do is plug this into the tangent sum equation. So we have tangent of theta plus tangent of 3 pi all over 1 minus tangent of theta times tangent of 3 pi. So now what you want to do is substitute. So we have tangent of theta, which is tangent of theta, and tangent of 3 pi, which would represent, 1.5 times around a circle. So therefore, it would be x over y, which is 0 over negative 1, which is equal to 0. So tangent of 3 pi would be 0 all over 1 minus tangent of theta times 0. So anything times 0 cancels out. So it'll be tangent of theta divided by 1, which is simply equal to tangent of theta. That is all we have for PI 17, sum and difference equation. I hope you enjoy it.